Hello everyone, and welcome back to the hidden world of numbers. In the previous lesson, we learned what matrices are, their different types, and why they are important in mathematics and real-life applications. Today, we will learn how to perform matrix operations, one of the most fundamental topics in linear algebra. By the end of this lesson, you will know how to add matrices, subtract matrices, multiply a matrix by a scalar, and multiply two matrices correctly. These operations are widely used in artificial intelligence, machine learning, robotics, computer graphics, engineering, physics, and data science. Let's begin. Part 1. Matrix addition. Matrix addition is one of the simplest matrix operations. Two matrices can only be added if they have the same order, meaning they must have the same number of rows and columns. To add two matrices, simply add the corresponding elements. Example: A equals 2, 3, 1, 4. B equals 5, 6, 7, 8. Now add the corresponding entries. 2 plus 5 equals 7. 3 plus 6 equals 9. 1 plus 7 equals 8. 4 plus 8 equals 12. Therefore, A plus B equals 7, 9, 8, 12. Matrix addition is straightforward because each element is added to the element in the same position. Practice question. Now try solving this yourself. A equals 1, 4, 3, 5. B equals 6, 2, 4, 1. Pause the video and calculate A plus B before checking your answer. Part 2. Matrix subtraction. Matrix subtraction follows exactly the same rule as addition. Again, both matrices must have the same order. Subtract each corresponding element. Example: A equals 2, 3, 1, 4. B equals 5, 6, 7, 8. Subtract each corresponding element. 2 minus 5 equals minus 3. 3 minus 6 equals minus 3. 1 minus 7 equals minus 6. 4 minus 8 equals minus 4. Therefore, A minus B equals minus 3 minus 3, minus 6 minus 4. Always pay close attention to negative signs when subtracting matrices. Practice question. Now solve this matrix subtraction. A equals 9, 8, 5, 7. B equals 4, 3, 2, 1. Find A minus B. Pause the video and solve it before moving on. Part 3. Scalar multiplication. A scalar is simply a real number. When multiplying a matrix by a scalar, multiply every element of the matrix by that number. Example: 3A, where A equals 2, 1, 4, 5. Multiply every element by 3. 3 times 2 equals 6. 3 times 1 equals 3. 3 times 4 equals 12. 3 times 5 equals 15. Therefore, 3A equals 6, 3, 12, 15. Notice that the size of the matrix remains the same. Only the values change. Practice question. Find 5A, where A equals 3, 2, 1, 6. Pause the video and calculate the answer. Part 4. Matrix multiplication. Matrix multiplication is different from every other operation. Before multiplying, always check whether multiplication is possible. The number of columns of the first matrix must be equal to the number of rows of the second matrix. If this condition is not satisfied, matrix multiplication cannot be performed. Example: A equals 1, 2, 3, 4. B equals 5, 6, 7, 8. To find the first element of the product matrix, multiply the first row of matrix A by the first column of matrix B. 1 by 5 plus 2 times 7 equals 19. Next, 1 by 6 plus 2 times 8 equals 22. Now move to the second row. 3 by 5 plus 4 times 7 equals 43. Finally, 3 by 6 plus 4 times 8 equals 50. Therefore, AB equals 19, 22, 43, 50. This process is called the row by column multiplication method. Practice question. Find the product. A equals 2, 1, 3, 4. B equals 5, 2, 1, 6. Calculate AB using the row by column method. Pause the video and solve it yourself. Important notes. Before performing any matrix operation, always check the required conditions. Matrix addition and subtraction are only possible when both matrices have the same order. Scalar multiplication multiplies every element of the matrix by the same number. Matrix multiplication follows the row-by-column rule. Remember that matrix multiplication is generally not commutative, which means AB is usually not equal to BA. Understanding these rules will help you solve more advanced linear algebra problems accurately. Real-life applications. Matrix operations are everywhere in modern technology. They are used in artificial intelligence to train machine learning models. Computer graphics use matrices to rotate, resize, and move images. Robots use matrix calculations to control movement and navigation. Scientists use matrices to analyze large datasets. Engineers use them to solve complex systems of equations. Even image processing, video games, and 3D animations rely heavily on matrix operations. Summary. Today, we learned 4 important matrix operations: matrix addition, matrix subtraction, scalar multiplication, matrix multiplication. We also learned the rules for performing each operation, solved practical examples, and discussed real-world applications. These concepts form the foundation for many advanced topics in linear algebra. Conclusion. Thank you for watching Lesson 5. I hope this lesson helped you understand matrix operations clearly. If you found this video useful, please like, share, and subscribe to the Hidden World of Numbers for more mathematics lessons. In the next lesson, we will study determinants, including their definition, properties, and solved examples. See you in the next lesson.